This is Ethan Walker from Weapon Science. The mission is an absolute success. The primary target has been neutralized with surgical precision. But instead of celebrating, a baffling, almost insane command crackles over the radio. Destroy our own multi-million-dollar helicopter left behind. Burn it to absolute ashes. Why would they do this? Why is the United States military so willing to blow up its own state-of-the-art assets, worth hundreds of billions of rupiah in hostile territory? To the untrained eye, a broken aircraft left behind is just a heap of useless, twisted metal. But through the cold, calculating lens of military intelligence, it is an existential threat. Imagine a stealth helicopter built with decades of secret research, forced to land in enemy territory due to sudden mechanical failure. Leaving this engineering masterpiece behind intact is equivalent to handing over the keys to your nation's most secure technological vaults. It is a goldmine waiting to be plundered. This single piece of wreckage holds the power to spark a massive technological leap for a rival nation, completely erasing the hard-won aerial dominance of the United States. To understand this deep-seated fear, we must look at the most famous real-world incident of asset denial in modern history, Operation Neptune Spear in 2011. In the dead of night, elite Navy SEALs infiltrated a high-walled compound in Abbottabad, Pakistan, to capture Osama bin Laden. But during the approach, a highly classified, top-secret stealth Black Hawk helicopter lost lift due to a localized vortex. It crashed hard, its tail section catching on the concrete compound wall. The helicopter was permanently disabled, unable to fly. With the clock ticking and local Pakistani forces rapidly mobilizing toward the crash site, the Navy SEALs faced a critical, high-stakes decision. Before boarding their backup transport, they had to execute a strict, non-negotiable protocol to destroy the fallen bird. In a matter of seconds, the pride of American military aviation was transformed into a roaring, massive fireball that lit up the Abbottabad night sky. The intense heat was meant to consume every scrap of classified technology. Yet, despite the sheer violence of the blast, a critical portion of the aircraft miraculously survived. The stealth black composite rotor tail, resting just outside the compound wall, escaped the main blast radius. Photos of this bizarre, highly unusual rotor design quickly went viral across the globe the next morning. It was an overnight geopolitical mystery, proving the existence of a secret stealth fleet the military had never acknowledged. This raises a fundamental, highly analytical question: what is the military so terrified of that they mandate the immediate, violent destruction of their own vehicles? Why not just let the dead machine rust away in peace? The answer lies in a terrifying engineering nightmare concept known as reverse engineering. Reverse engineering is the meticulous process of deconstructing a finished product to understand its internal mechanics, materials, and design, with the ultimate goal of copying or improving it. In the high-stakes theater of modern warfare, a downed aircraft is not a pile of garbage. It is a priceless library of secrets. A single modern stealth jet or helicopter represents millions of hours of intense research, countless failed experiments, and trillions of dollars in development. Letting a rival nation capture this asset intact is like handing them a master key to your entire national defense strategy, bypassing decades of hard work. To fully grasp the scale of this threat, we must dissect the highly specific, incredibly sensitive technologies hidden inside these machines. One of the most closely guarded secrets is the advanced optoelectronics and infrared tracking systems used to detect threats long before they can be seen by human eyes. Have you ever heard of a quantum well infrared photo detector, or QWIP? This is a highly sought-after component that rival nations desperately want to get their hands on. It is not your run-of-the-mill thermal camera. This sensor operates purely at the microscopic, counterintuitive level of quantum mechanics. A QWIP sensor uses artificial potential wells engineered into semiconductor crystal structures to capture infrared photons with unbelievable precision. Nations like Iran are highly motivated to acquire this cutting-edge optoelectronic technology to upgrade their own defense networks and track stealth aircraft. Why is this quantum sensor so critical? Because it is specifically calibrated to detect the incredibly faint thermal signature of American jet engines from hundreds of kilometers away. No matter how stealthy an aircraft is, friction with the air and engine exhaust always generate heat, leaving a faint trail. If hostile engineers manage to salvage an intact QWIP sensor from a downed reconnaissance plane, they will dissect it in a clean room. They will measure the nanometer thin layers of the semiconductor crystal, learning exactly which infrared wavelengths the American military is trying to hide and how they calibrated it. With this stolen data, the enemy can do two incredibly dangerous things. First, they can design advanced heat seeking missiles that are completely immune to standard flares because they are programmed with the exact thermal fingerprint of the jet. Second, they can develop their own thermal shielding materials. This is why even the smallest electronic chip or optical lens inside a military aircraft must never fall into enemy hands. A single silicon chip no larger than a fingernail has the potential to completely dismantle and reverse decades of carefully built aerial supremacy in a single stroke. This brings us to another dramatic geopolitical incident: the crash of an American F-16 fighter jet in hostile territory. Why would the United States government and even the president authorize a massive high-risk rescue operation costing up to $600 million for just a single downed pilot? From a purely humanitarian standpoint, saving a life is always the right thing to do. But in the cold, calculating mathematics of military strategy, there is an even larger invisible value at play. A highly trained fighter pilot is not just a soldier. They are a walking biological hard drive packed with secrets. A pilot holds intimate knowledge of classified communication protocols, active radar frequencies, blind spots in enemy air defenses, and highly sensitive squadron maneuvers. If captured alive and subjected to intense interrogation, they could inadvertently expose the entire operational network of the military. Beyond securing the pilot to prevent critical intelligence leaks, these daring rescue missions always carry a vital secondary objective: locate and destroy the downed aircraft. The elite rescue team is tasked not only with extraction, but with thoroughly sanitizing the crash site of any technological footprint. An F-16 fighter jet sitting in enemy territory is an absolute goldmine of military intelligence. Every single minute the wreckage remains exposed is a minute closer to a major security breach. Enemy forces will quickly mobilize heavy transport trucks and salvage teams to haul the prize away. You might wonder why regions like the Middle East, particularly around nations like Iran, remain such intense, highly volatile geopolitical hotspots. Why does a single aircraft crash in this region trigger immediate high-level panic? The answer is tied directly to the lifeblood of modern civilization: oil. Without a steady, massive flow of crude oil, the world's largest military machines would grind to an immediate rusted halt. Supersonic fighter jets, nuclear aircraft carriers, and heavy armored divisions would be rendered useless. Oil is the thick blood pumping through the veins of global military logistics. Controlling strategic oil reserves means holding absolute leverage over the economic and physical survival of nations. This is why global superpowers expend massive resources to secure these energy shipping lanes. Cutting-edge military hardware is built in large part to police and protect these vital trade routes. If a highly advanced American stealth asset falls into a hostile, oil-rich nation, it threatens to shift the balance of power overnight. If they reverse engineer that technology, they can easily build counterweapons to block oil straits, threatening the energy security of the entire Western world. So, when an advanced aircraft is going down, what is the very first line of defense to prevent this technological catastrophe? Before any explosives are ever detonated, the pilot triggers an automated digital defense protocol known in classified circles as Zero Ice. Think of Zero Ice as a digital self-destruct button for the aircraft's brain. When a pilot realizes the plane cannot be saved and a crash is inevitable, they press this button. It doesn't cause a physical explosion, but it completely destroys the core computer systems in less than a second. Upon activation, a high-voltage electrical surge floods the memory storage units. Every single byte of cryptographic keys, secure communication codes, targeting algorithms, and military GPS coordinates is permanently vaporized. A multi-billion-dollar software suite is instantly reduced to meaningless zeros. Why is this digital purge so absolutely critical? Because if an enemy extracts active encryption keys from the computer, they could theoretically compromise highly secure military satellite networks. They could eavesdrop on classified communications between generals planning active battle strategies. Even worse, with these stolen electronic codes, enemy aircraft could spoof military radars masquerading as friendly forces. They could slip right through air defense networks without triggering a single alarm. The Zero Ice protocol guarantees that even if the hardware is captured, the brain is dead. But this raises an important question. If the computer's brain is wiped clean, why must they still physically destroy the metallic husk of the aircraft? Why not leave the empty shell behind? The truth is, in modern engineering, the physical architecture of the hardware itself is a highly classified blueprint. Take, for instance, the revolutionary radar-absorbent material, or RAM, that coats stealth aircraft. This is not ordinary paint. It is a highly complex polymer matrix embedded with microscopic magnetic particles. This coating is engineered to trap incoming radar waves and convert their energy into harmless heat. If a rival nation's engineers salvage even a square inch of this peeling paint from a crash site, they will rush it to a state-of-the-art laboratory. Using advanced electron microscopes and mass spectrometers, they can easily decode the exact chemical recipe at a molecular level, skipping decades of trial and error. Once they unlock the chemical secrets of the RAM coating, they can easily mass-produce it to shield their own aircraft and naval vessels, instantly matching American stealth capabilities. Beyond material composition, the precise physical geometry of the aircraft also holds incredibly valuable science. Consider the unique, curved design of a stealth helicopter's main rotor blades. The specific angles, twists, and composite materials are carefully engineered to minimize acoustic signatures, allowing the helicopter to fly silently through the night. It is a masterclass in aerodynamics and acoustics. Similarly, the shape of the engine exhaust nozzles is meticulously designed to mix hot exhaust gases with cold ambient air almost instantly. This suppresses the aircraft's thermal signature, making it incredibly difficult for enemy heat-seeking missiles to lock onto the machine during combat. These physical shapes are the hard-earned results of billions of dollars spent on supercomputer simulations and wind tunnel testing. If enemy engineers get to scan these shapes, they can simply copy the dimensions using high-resolution 3D laser scanners, gaining a massive shortcut in aviation design. By importing these scanned files into their own fluid dynamics software, they can replicate the exact aerodynamic and stealth performance in their own fleets. This is why the military enforces strict asset denial protocols. They must ensure not a single bolt or panel remains intact for study. This leads to a fascinating engineering question. How exactly do special forces completely obliterate a 12-ton titanium aircraft in a remote location under extreme time pressure in pitch darkness? Why not just use standard military plastic explosives like C4? C4 is highly powerful, lightweight, and incredibly reliable for blowing up concrete bridges or steel structures. But standard explosives rely on kinetic force, a massive high-pressure shockwave that shatters metal into thousands of pieces, scattering them across a wide radius. To a casual observer, those scattered, twisted fragments look like useless junk, but to a highly trained military engineer, those pieces are a giant, three-dimensional puzzle. Enemy salvage teams will meticulously collect every single shard of metal from the site, no matter how small. In a bright hangar, they will lay out these fragments, reconstructing the aircraft's physical structure piece by piece. Because kinetic blasts do not alter the molecular structure of materials, the radar-absorbent paint, the microchip architecture, and the metal alloys remain completely intact and readable. To truly secure these secrets, the military needs a method that doesn't just break the asset apart, but fundamentally changes its physical state and chemical composition forever. The brilliant solution to this problem is a classic, incredibly powerful chemical reaction: thermite. Thermite is not an explosive. It does not produce a loud bang or a destructive shockwave. Instead, it is a simple mixture of metal powders, typically aluminum powder and iron oxide, commonly known as rust. But when ignited, it triggers an incredibly violent exothermic redox reaction. Once ignited by a high-temperature source like a magnesium fuse, the aluminum aggressively strips oxygen from the iron oxide. This reaction releases an unbelievable amount of thermal energy, reaching temperatures well over 2,500 degrees Celsius in a matter of seconds. To put that into perspective, that is twice as hot as volcanic lava. This extreme heat easily melts right through any thermal protection or armor plating. Even heavy engine blocks made of aerospace-grade titanium, the same metal used to build rockets, will melt and flow like warm butter. What makes thermite the ultimate weapon for asset denial is its chemical self-sufficiency. Unlike a standard fire, which requires oxygen from the surrounding air to burn, thermite carries its own internal oxygen supply bound tightly within the iron oxide powder. Because of this, a thermite fire is virtually impossible to extinguish. Pouring water, spraying foam, or smothering it with sand will do absolutely nothing to stop it. It will continue to burn violently even if submerged deep underwater or placed in a complete vacuum. When special forces deploy thermite grenades on a downed helicopter, they place them directly onto critical, high-value components. The main engine block, the rotor hub, the cockpit avionics bay, and the encrypted computer storage drives. Once ignited, the cascading heat melts the delicate silicon wafers of the microprocessors, blending the gold, copper, and silicon into a useless molten blob. The advanced quantum infrared sensors lose their precise crystalline structure, rendering them completely unreadable. The classified radar-absorbent paint coating on the fuselage is vaporized into toxic gases and pure carbon ash. Every trace of aerodynamic shape, material science, and structural engineering is utterly erased. What remains after the reaction cools is nothing but a worthless lump of mixed metals. This slag contains absolutely zero useful data for enemy engineers. The military successfully protects its intellectual property by turning a multi-million-dollar asset into worthless scrap metal. Yet history shows that even the most perfect protocols can encounter unexpected failures in the chaos of real combat. Let's return to the 2011 Abbottabad raid. As we discussed, the unique stealth tail rotor of the crashed Black Hawk survived because it was hanging outside the compound wall, away from the thermite charges. The morning after the raid, Pakistani military forces quickly secured this highly classified prize. The wreckage was transported to a secure research hangar, but Pakistan didn't analyze this technology alone. Multiple international intelligence reports confirmed that senior military engineers from China were invited to examine, measure, and take material samples of the stealth tail rotor. This was a textbook example of how a minor slip-up in an asset denial protocol can yield a massive intelligence windfall for rival nations. Only a few years after the Abbottabad raid, China began showcasing its own advanced next-generation military helicopters. Aviation experts were stunned to find that these new Chinese designs featured tail rotors with acoustic dampening curves and aerodynamic profiles that were nearly identical to the crashed American stealth Black Hawk. It was clear evidence of successful reverse engineering at play. This quiet, invisible war fought inside laboratories and supercomputers is the true battlefield of modern geopolitics. Today, nations do not just fight with kinetic weapons. They fight to steal decades of expensive research in a fraction of the time, tilting the technological scale in their favor. For the United States, developing a single breakthrough material like RAM or a quantum sensor takes decades of trial and error and billions in funding. For a rival nation, copying an existing physical sample is infinitely cheaper and faster, creating a highly dangerous asymmetrical disadvantage. This is why whenever a high-tech asset is forced to make an emergency landing in hostile territory, the military's immediate priority is not the financial loss of the machine. They will gladly incinerate a $100 million aircraft in an instant to protect trillions of dollars in future technological advantage. This cold, logical calculation shows how fragile technological dominance is in the digital age. A nation can rule the skies for 30 years, but that dominance can crumble in months if a single palm-sized piece of secret material falls into the right hands. To combat this, engineers are developing mind-blowing new solutions. With rapid advancements in artificial intelligence and molecular scanning, future reverse engineering will become even faster. An enemy might not even need a large chunk of metal. A few microscopic dust particles of stealth coating scraped from the air might be enough for an AI to reconstruct the formula. To counter this hyper-advanced threat, military scientists are researching self-destructing materials that dissolve at a molecular level. Imagine a stealth coating engineered to completely degrade into harmless, non-toxic organic dust the moment it is exposed to atmospheric oxygen due to a structural breach. They are also designing transient electronics built from specialized biodegradable polymers. If an aircraft crashes, these microcircuits are engineered to melt into a useless puddle of liquid gel within an hour under normal room temperatures, leaving absolutely nothing for an enemy to salvage. This presents a fascinating, highly ironic paradox in modern military science. You must build the most rugged, durable, and advanced war machine capable of surviving extreme combat environments. Yet at the exact same time, you must design it to easily and completely self-destruct in seconds. Until these futuristic, self-dissolving materials are fully realized, elite special forces will continue to carry simple, highly reliable thermite canisters into every secret operation. This simple, century-old chemical mixture remains the ultimate shield for the most advanced technologies of the 21st century. Now you understand the deep scientific and geopolitical reasons behind that seemingly insane command to destroy our own assets. Burning a downed helicopter is not a sign of panic or tactical failure. It is a highly calculated, cold-blooded defensive move to protect national security. From the high-stakes Navy SEAL raid in Abbottabad to the dramatic rescue of a downed F-16 pilot in hostile territory, asset denial remains a cornerstone of modern military doctrine. As long as nations build multi-billion-dollar secrets, the blinding fire of thermite will continue to burn them away. Every charred frame and solidified pool of metal left behind in a foreign desert is a silent testament to the brutal, endless war for technological supremacy. In this high-stakes game, keeping a secret is the ultimate weapon, far more powerful than any missile, armor, or stealth design. And the absolute best way to keep a secret in hostile territory is to ensure that nothing remains but ash, molten titanium, and an unsolvable mystery. This is also a vital lesson for developing nations building their own defense industries. Protecting your intellectual property is just as crucial as building the weapons. Ultimately, the world of military intelligence is an endless, high-stakes game of cat and mouse. One side will always innovate, creating advanced codings and encryption, while the other will always search for a way to capture, dissect, and replicate those breakthroughs to close the gap. And in the middle of this dangerous game, the simple thermite grenade and the digital zero-ice protocol stand as the final absolute line of defense. Asset denial is not just a policy. It is a manifestation of rational, high-level paranoia that a single loose bolt could change global history. So, the next time you read a news headline about a crashed military drone or jet being immediately blown up by its own forces, don't view it as a waste of taxpayer money. View it as a highly successful, incredibly precise scientific operation designed to defeat enemy espionage. The white-hot chemical fire that melts a titanium engine block is a triumph of thermodynamics over reverse engineering. The millisecond purge of a cryptographic drive is a victory of cybersecurity over physical spionages. Every step is engineered with the exact same precision as the aircraft itself. In the future, the war between creators and copycats will only intensify. Radar-absorbent paint might be replaced by optical metamaterials that bend light, making vehicles completely invisible to the naked eye. Quantum sensors might give way to microgravity detectors tracking mass from orbit, but no matter how advanced technology becomes, the core principle remains unchanged. The greatest weapon is the one whose secrets can never be deciphered by the enemy. If it falls, it must be destroyed without hesitation. What do you think? Is reverse engineering a clever strategy or an unethical shortcut? Does asset denial make perfect sense to you now? Share your analytical thoughts in the comments below, and let's discuss the fascinating science and complex ethics of modern military geopolitics. If you enjoyed this deep dive into the physics and chemistry of warfare, hit that like button. Make sure you subscribe to Weapon Science and turn on the notification bell so you never miss our latest high-production scientific documentaries. Share this video with anyone who dreams of becoming an aerospace or military engineer. Thank you so much for watching our channel. Your support helps us continue producing deep, highly detailed scientific content. Keep exploring the incredible science that shapes our global security and geopolitical landscape. This is Ethan Walker from Weapon Science signing off. Stay curious, stay safe, and see you in the next video.